Here we are looking at inverse trig functions. So inverse trig functions, we have inverse sine, inverse cosine, and inverse tangent. I just want to touch right away, first of all, that we're also going to say with inverse tangent, inverse cosine, inverse sine, inverse cosine, inverse tangent, we could also write it as and say it as arc sine of x, arc cosine of x, and arc tangent of x. So from this point forward, you'll be hearing me say arc sine, arc cosine, and arc tangent when I'm referring to the three inverse functions. So these, when they are considered functions, our textbook looks at them as if they're functions. The domain is restricted. If we think of what's needed to have an inverse, we need to pass the horizontal line test, and cosine, tangent, and sine, none of them would pass the horizontal line test. So we restrict their domain so that we can have an inverse. So we see that the domain of sine, of arc sine, and the domain of arc cosine is between -1 and 1, whereas the domain of arc tangent is all real numbers, whereas the range for each is also restricted. So now what I like to think about is, write it down right about here, is when we were focusing on just trig functions. So we have this box, that's a trig function. We were putting into it an angle measure. And what we were getting out of it, once we put an angle measure into a trig function, we were getting out of it a ratio for side lengths. Well, with their inverses, so now imagine we're focusing on the inverse trig functions. It's the exact opposite order. With a trig function, we are inputting into it a ratio of side lengths. And it is spitting out, its output is an angle measure. Most often, when we are doing this by hand, the angle measures that we are obtaining from the functions are going to be in radians. And from radians, if we needed to, we can convert them to degrees. But knowing that with an inverse trig function, we're inputting into it a ratio of the side lengths, and it's outputting an angle measure, what this says is that for arc sine, arc cosine, and arc tangent, we are going to be, when we're given an answer, for arc sine, it's the angle measures we're going to be focusing on are from -π/2 to π/2. So -π/2 to π/2, we're focusing there on the angles within quadrant 1 and quadrant 4. And if we have an angle within the other two quadrants, we would just revert back to these two using the reference angles. So with arc cosine, thinking of the unit circle, 0 to pi, well, that's 0, pi. That's the upper portion of the circle. So any angles that we're focusing in quadrants, so this would be quadrant 1 and quadrant 2. So any angles within quadrant 3 or 4, we would just simply revert back to quadrant 1 and 2. And then with arc tangent, it's going to be much like arc sine. Arc tangent, we're within -π/2 and π/2. So the purpose of, with the restricted domain, if you recall, if let's say I have a negative value here, that negative value also showed up within quadrant 3. And if I had a negative or positive value in quadrant 1, it also showed up in the positive value in quadrant 2. So we're able to take from the other quadrants and go back to the domain. That's going to be rather easy to do when we look at examples. So the key thing with these inverse trig functions is that we're inputting into it a side length and it is outputting an angle measure. Input side lengths, output angle measures. So let's look at a couple of examples. So let's say we have, to begin here, let's say that we want to evaluate, all of these are going to be evaluate. Let's say we want to evaluate the arc sine of 1/2. Okay, so how we're going to think of this, and I'm going to actually write this down, is we want to think is along the unit circle, sine, cosine, or tangent is blank at blank. So how I would think of it here. So along the unit circle, sine is 1/2 at where? So knowing our unit circle, we would say sine is positive 1/2 at pi over 6. And at, so in quadrant 2, that would be 5 pi over 6. But knowing the range of arc sine, we are only within quadrants 1 and 4, so we would disregard this value, and we would say that the arc sine of 1/2 is pi over 6, or in degrees, this would be 30 degrees. So let's try another. I feel like the key to success is asking ourselves this question every single time. So let's say we want to find the arc sine of negative square root of 3 over 2. Okay, so asking this question. Along the unit circle, sine is negative square root of 3 over 2 at, okay, so square root of negative 3 over 2, we are at 4 pi over 3, and the others would be 5 pi over 3. But thinking we're in quadrants 1 and 4, so 4 pi over 3 is in quadrant 3, that's not good for us. But 5 pi over 3, that's not within our range. Our range went from negative pi over 2 to positive pi over 2. So 5 pi over 3, if I'm thinking of the unit circle here, little unit circle, I'm right here for 5 pi over 3. Okay? So that's going around this way. So thinking of coterminal angles, we're looking at really a negative pi over 3 angle measure. So again, the importance of knowing coterminal angles and knowing the quadrants angles are within. All right, so what about we want the value for arc cosine of negative square root of 2 over 2. All right, so along the unit circle, cosine is negative square root of 2 over 2 at, so it's going to be over 4, so negative square root of 2 over 2, that's going to be 3 pi over 4 and 5 pi over 4. But thinking of our range, we would be at 3 pi over 4, or 135 degrees. And actually, let's go on to the next page. Let's say we have, just keep them going. Let's say we want to evaluate the arc cosine of 1. Okay, so the arc cosine of 1. So along the unit circle, cosine is 1 at, okay, so cosine is 1, we really have one location, and that's at 0. So the arc cosine of 1 is 0 pi, or we'll write pi here so we know it's an angle measure, is 0 pi. And if I wanted the arc cosine of -1, well, we would be at pi. So then let's say we would like to evaluate the arc tangent of 1, positive 1. So along the unit circle, tangent is 1 at, so that would be a couple options. We have pi over 4 and 5 pi over 4. So we're just with tangents with positive 1 in the first and third quadrant, but tangent's range is between negative pi over 2 to positive pi over 2, so this is it's outside its range. So we would say arc tangent of 1 is pi over 4. And then the arc tangent of square root of 3. Okay, so square root of 3, our tangent along the unit circle is square root of 3 at, and if you do not know this, tangent is square root of 3 at pi over 3, which means that it would also be positive square root of 3 at, I guess this would be what, 4 pi over 3? Yeah, it'd be square root of 3 at 4 pi over 3, but we disregard this value because it's not within the range. Okay, let's see what other examples we have here. So now this is just with single inverse functions. The arc sine, arc cosine, or arc tangent of a length, and we are given an angle measure. I'd like to say it now. We could evaluate this using a calculator, but if you do use a calculator, make sure you are in the correct mode, whether degrees or radians, and it all depends on really the directions in the problem. So going further, let's say we have the arc sine of 5 pi over 6. Okay, so the arc sine of 5 pi over 6. If you remember, 5 pi over 6 is not within the domain. So really what we're saying right now is, well, okay, let's look one piece at a time. So sine of 5 pi over 6, that we can evaluate. Sine of 5 pi over 6, we are in the second quadrant. So sine of 5 pi over 6, I forgot the arc, so we're just going to throw the -1 here. So is going to equal positive 1/2. So notice I evaluated the inner portion first. So now I take the arc sine of 1/2. So along the unit circle, sine is 1/2. Well, we already saw it's going to be 1/2 at 5 pi over 6, but that's not within our range. So it would also be 1/2 at pi over 6. So you might notice something here with the arc sine and sine, but let's try another one. So let's imagine we have for a moment the sine of arc sine of, let's say we want the arc sine of square root of 3 over 2. Okay, so the arc sine is going to give us an angle measure, and sine of an angle measure gives us a length. So let's think of this. So arc sine of 3 pi, or square root of 3 over 2, that is going to be, let's see, square pi over 3, and sine of pi over 3, that would be square root of 3 over 2. So notice, sine arcsine essentially gave us the same value. And that should make sense because these are inverses of each other. So if I took the square root of x squared, we would get x. If I took the natural log of e to the x, we would get just x. That's the kind of the whole, not really purpose, but something really nice about inverse functions is what it does for us here. So let's look at a couple others that don't match up like we're seeing. So let's say we have cosine of arctangent of -1. Okay, so arctangent of -1. We're going to get an angle measure from this, and from the angle measure, we'll take the cosine of that. So look at cosine. See, tangent is -1 at. Okay, so I'm thinking here. So tangent is -1 at 3 pi over 4, and at, that would be what, 7 pi over 4. But 7 pi over 4 we would have to convert to negative pi over 4. Okay, right? Sounds right. Because the range for tangent is from negative pi over 2 to pi over 2. So then the cosine of negative pi over 4 is going to be, so negative pi over 4 is in the first or fourth quadrant, so we are positive square root of 2 over 2. Okay, so let's try another. Actually, this looks to be our last. No, it's not our last. So sine of arc cosine of square root of 3 over 2. So cosine is square root of 3 over 2 at, that would be pi over 6, and let's see, where else would it be? 5 pi over 6. Correct? Is that right? No. 11 pi over 6. First and fourth quadrant. So 11 pi over 6 is not within the range of arc cosine, so we're saying we're now wanting the sine of pi over 6, which is 1/2. So one last example to close off this lesson. See if I can get this under 20 minutes. Let's say we have the tangent of arc cosine of -5 over 13. How in the world would we talk about that? So thinking of arc cosine, -5 over 13 is not something we're familiar with, especially with the unit circle. So like, what do we do here? Let's draw a reference triangle. Okay, so with -5 over 13, that's going to be for us cosine, that's going to be in the second quadrant. Okay, so -5, 13, so that's -5, and then 13. So you can quickly use the Pythagorean theorem, and we're going to find that this unknown side here is 12. So 13 squared minus 5 squared is 144, and square root of 144 is 12. So this is our angle measure. So we don't know what the angle measure is. So again, arc cosine is going to give us an angle measure. We don't know what this angle measure is, but we can take the tangent of this angle measure. So the tangent of this angle measure is going to be positive 12 over -5. So we've seen arc cosine, arc sine, arc tangent, combining them, placing them within another trig function and what's done there. I wish you the best of luck when practicing this. We're going to look at more into inverse trig functions in our next lesson, and I'll see you then.